Welcome to Spark Academy, dear student. I am Nityanand Ghosh, physics faculty here. Today I will be explaining about motion of a particle or a body in a on a plane. Plane means actually 2-dimension or it will be 3-dimension. Last time I explained you motion in a particle or a body in a straight line. This is plane. So, what are the topics covering this particular thing? The topics which we cover is actually the vectors. So, the direction of the vector is not restricted to only in one dimension, but it will be in 2 or 3 dimensions. So, we have to actually explain the concept of vectors, and then those vectors, with the help of those vectors, you have to find out the relative speed or relative velocity of a body, and then you have to I will explain you about what you call the projectile motion. Projectile motion, an oblique angle, or suppose in a horizontal, suppose a aeroplane is going and some body is dropped, then what are the different parameters, and then uniform circular motions. Now, all these things will be covered under this motion. Then there will be a boat problem. The boat is going. Boat is having some speed, and the water current will be having. Water will be having some speed. The boat has to reach from one bank to the other bank. At what angle it has to start, or what is the shortest time, or what is the shortest distance to reach the destination. All this concept will be covered under motion in a plane. Okay. So let me start with the basics. As you know, these are the two quantities. Scalar will be there inside vector. Scalar is just a magnitude, and vector is nothing but magnitude as well as direction. And already you know that scalar magnitude means these are the example. Mass, speed, time, temperature, distance, energy, work. I can give more example. Work, then current. All these are scalar quantity. Why it is a scalar quantity? You have to see the unit. By seeing the unit, you can know that it involves only magnitude. Vectors, of course, will be having magnitude as well as it will have direction. For example, force, mass into acceleration, velocity by time. Velocity is a vector quantity. Displacement means magnitude in particular direction. Then you have acceleration vector quantity, velocity by time. Momentum is mass into velocity. Velocity is a vector quantity. Weight is nothing but mass into gravity. Gravity is again acceleration due to gravity. Then you have you have angular momentum, you have torque. All there comes under vector quantities. Okay. So basically, by seeing the units, you can infer that it is a scalar quantity. For example, speed 50 kilometers per hour is not saying which direction. Then you have mass just 10 kg. Okay, time 5 seconds, temperature 25 degrees centigrade, just magnitude involved. Distance 100 meters. Which direction, what direction, nothing is mentioned. Okay. Energy 500 joule. Work is also energy, kinetic energy, potential energy, they all come under the scalar quantity. Vector quantity means, suppose if I say 50 kilometers per hour, you are going in north direction. Then it is a vector quantity. Then you have force 20 Newton pointing in the right direction. You can apply a force at some angle. What is the example of force acting some angle? The example is perambulator. The heavy roller, you roll on a cricket pitch. If you have carefully noticed, so much of physics involved there. You don't roll the roller by applying a horizontal force. You cannot, because too much of friction is there between the heavy roller and the ground. So you apply force at some angle. So if you apply force at some angle means that vector will be having, you have to resolve the component of that vectors. That vector is at some angle, so you have to resolve the component of that vector. If the vector is applied at some angle, you have to resolve the, suppose this is the force, this is the theta, your horizontal component and vertical component. Horizontal component will be f cos theta, vertical component is f sin theta. This force can be downward force also. Okay, this force can be like this also. So work is nothing but the application of the force and the distance moved should be in the straight line. So that is one example, of force acting at some angle. Displacement 5 meter east. So so many problems are there. Suppose the body is traveling in east, west, north, west, south direction, north of east, east of south. So you have to very carefully see what is the direction of that motion. Accordingly, you have to resolve the component of that vector. Okay, momentum is nothing but mass into velocity. Velocity is meters per second, again it's a vector. Then moving in the forward direction, direction is involved. Weight is nothing but mass into gravity. Gravity is nothing but acceleration due to gravity. The value of g is 9.8 meters per second square. Okay, or 10 meters per second square also you can. Then that becomes a weight. Weight is nothing but a force which is being applied vertically or horizontally. Okay. Now these are some of the pictographic explanation. These are the several types of vectors. Zero vector, unit vector, position vector, collinear vector, equal vectors, coplanar vector, orthogonal vectors. See, zero vector means zero magnitude. Vector is there, but it has got zero magnitude. What are the example? Example, suppose a table is there, a body is lying on the table. This is the mass m. So its horizontal is downward force is mg. Downward force. It is balanced by normal reaction R, because this particular body is lying stationary on a table. So two forces acting in opposite direction, they are cancelling out. So if two equal vectors, they are in opposite direction, they will cancel out and the resultant will be 0. So that is a zero vector. Equal vector, of course, they are traveling in same direction. Negative vector means if one vector direction is like this, another vector will be opposite. Okay. Then orthogonal vector means both the vector will be perpendicular to each other. Orthogonality condition is there. Orthogonal means two vectors will be perpendicular to each other. Collinear vector, collinear means same direction. The two vectors are in the same direction. Okay, collinear points we say, points lying on the same line. So this is an example of collinear vectors. Okay, now what are coplanar vector? Coplanar vectors is the vector lying on the same plane. Suppose xy plane or yz plane or zx plane. Suppose for example, I draw a diagram. Suppose this is x, this is y, and of course this is z. This is origin O. So suppose if this is the direction of your linear momentum at an angle theta, suppose, okay, once again I will draw, this is x direction, y direction, z can be perpendicular to the board or z can be, suppose if this is z, this is z, this is x, this direction is x, this direction is This is origin, this direction is suppose y. Suppose this point some P is the position vector R at an angle theta, and I apply a linear momentum P which is equal to mass into velocity. Linear momentum P which is equal to mass into velocity. This is its state direction. Then this linear momentum, this is R, this is P. Then R cross P will be angular momentum. Angular momentum direction is perpendicular to R and P. So L is equal to R cross P. So this R and P is in XY plane. So what I want to impress upon you is that suppose two vectors are lying in the same plane, they are coplanar vectors. It can be xy plane, it can be yz plane, it can be xz plane. Okay. Now these are some example of scalar quantity. Once again, length, area, volume, speed, mass, density, pressure. Pressure is force per unit area, F by A. Okay. So if you apply that force, sometime work, force into distance is work. Work is a scalar quantity. Okay, if you change the formula, pressure is equal to force into velocity, then it will be a vector quantity. So actually it may not be in this particular thing. Then temperature, energy, entropy, work, power. Power is rate of doing work, work by time. Work is force dot F dot S, no. Dot product of two vectors will be a scalar. Time is a scalar, so it is a scalar. Similarly here, actually pressure should come here. Displacement, velocity, acceleration, momentum, force, lift, going up, coming down, drag, viscous drag, thrust, force per unit area. Okay, so these are vector quantity. Okay. Now, what are the different types of unit vector? Unit vector is nothing but unit vector has got magnitude 1. Unity means 1. And how you write unit vector? Suppose position vector is known. Suppose the position vector is A. What is unit vector? Unit vector will be position vector by its magnitude. Okay. X, Y, Z are that point and I, J, K are the unit vector. Here it is explained suppose I have position vector. Suppose this is the Cartesian coordinate system. Z axis is perpendicular to this plane, and suppose this point is x comma y comma z. So your position vector is nothing but O to P. OP is the position vector. X, I, Y, J, Z, K. So I, J, K are the unit vector. Instead of writing like this, suppose if I write like this, 2I cap plus 3J cap plus 5K cap. What is the physical meaning? I, J, K are the unit vector. I cap is the unit vector in x direction, J is the unit vector in y direction, and K is the unit vector in the z direction. That means you are supposed to go 2 units in x direction. I you can consider as 1, 2 into 1, 2. Similarly, J is the unit vector 1. So 3 units in the y direction. Similarly, 5K means 5 unit in the z direction. So position vector is represented by like this vector xi plus yj zk, and its magnitude is magnitude of OP or R is equal to square root of x square plus y square plus z square. Okay. Now what is a null vector? I told you null vector has got 0 magnitude and no direction. Okay, the difference between two equal vectors is null vector. It cancels out. Okay. Now some more example explicitly, these are the examples. Some example, unit vector ka example. See, the vector ijk pointing along x, y and z. For example, suppose 1 comma 0 comma 0. You can also write this as 0 comma 1 comma 0. You can also write this as 0 comma 0 comma 1. Okay, 1 should be there. Here in x direction you have to go 1 unit, y and z 0. Similarly here y direction 1 unit, x and z 0. This is nothing but your x comma y comma z. Okay. So now this is a example. This can be example of unit vector. See, wind direction. Suppose if a wind blows northeast at 1 meters per second, its velocity direction. So northeast means, suppose north direction you take 1 and east direction you take 1. So its resultant will be the vector passing through the origin. So if you apply Pythagoras theorem, it will be square root of 1 square plus 1 square, that is root 2. So if you want the direction, then this will be a unit vector will be equal to sin theta will be 1 by root 2. So this is one way wind direction you can measure. Okay. This is of course the direction of that vector which is given here. Normalized force. What is normalized force? Normalization. In maths you have studied normalization, but okay, normalized force is nothing but pushing a box with any force creates a direction. Shrinking that direction arrow to a length of 1 gives you its unit vector. Suppose you apply a force to a box, you push a box with any force, so it will go from one direction to other. Suppose you stretch the box or you push a box, so it will go from one direction to other direction. Then you compress the box so that its unit is 1. Okay, so then it can be a unit vector. These are some of the examples which you can visualize. See, what is the example of null vector? Null vector means zero magnitude. So a parked car has a velocity vector of 0, 0 comma 0 comma 0, because it is not moving. Okay. Now tug of war, this is also 0 vector. You know, tug of war, suppose 10 equal people, who is applying together force that side and this side, center, that side and this side, suppose the forces are equal, then the center will not move. That can be a 0 vector. Two equal teams pulling a rope in opposite direction creates a net force vector, that is 0, opposite direction. Object at rest, a book sitting on a table feels gravity pulling down and the table pushing up. This cancels out the net force. As I told you the other example, this example I told you, this example, okay, I will okay, I can draw this. Suppose this is the board, this is a object lying of some mass m. Okay, its downward force will be mg acting in the downward direction. It will be balanced by normal reaction r. So the book will be at rest. Even though two forces are acting on this particular book, but it is equal and opposite, it is cancelling out. So that can be example of 0 vector. Now, position vector, what is the example? Suppose GPS system, GPS coordinate. Okay, see, you are well versed with GPS system. Suppose if a coffee shop is 3 blocks east, in east direction you go 3 meter, let's say, and 4 blocks north direction you go 4 meter. So then your current location will be, position vector will be 3 comma 4. So that can be a position vector. Similarly, a flying drone. Suppose the drone is flying 50 meter in east direction and 20 meter in the north direction and 10 meter high. Okay, suppose 50 meter is in x direction, 20 meter in the z direction, and this 10 meter high is in the z direction. 20 meter north direction is in the y direction. 50 meter east is in the x direction. 20 meters north is in the y direction, and 10 meter high is in the z direction. Then position vector will be 50, 20, 10. Then you know, if you are well versed with chess board, you know, a knight placed on the third file and fourth rank of a chess board has a position vector 3, 4. Now some numerical problems are asked. They ask you about the angle subtended between the vector and its resultant, or between two vectors. Okay, so resolving the vector in x and y direction is very important. So resolution of a vector. So vector r can be resolved in two mutually perpendicular component rx and ry. The projection of r along x axis is called horizontal component. Suppose if this is vector r, okay, is the projection of this r in x direction is nothing but is given by rx. Rx is r cos theta, and the projection of this vector r in y direction will be equal to r sin theta. These two parallel vectors, no, here also you can take r sin theta. So basically, suppose, and this is the magnitude r resultant. Suppose if they ask you the angle between this and this, suppose theta is the angle, then you can say that this horizontal by hypotenuse is cos theta. So therefore cos theta is equal to this divided by r. Are you following? Of course it will cancel out and it will give r. So the resolution of this vector r is rx cos theta in the x direction, ry sin theta in the y direction, and the resultant will be given by its magnitude. Magnitude is nothing but square root of, you know, the magnitude. Magnitude will be nothing but square root of rx square plus ry square. Rx square you can take it as r cos theta whole square plus ry as r cos theta whole, r sin theta whole square. Sin theta whole square. You can see that when you simplify, r square common, cos square theta sin square theta 1, square root of r square is r only. So this is basically the magnitude. Magnitude is square root of rx square plus ry square. Now, resultant of number of vectors. So resultant is a single vector that gives the total effect of number of vectors. Resultant can be found using, these are very important: triangle law of vectors, parallelogram law of vectors, polygon law of vectors. So these are used in solving numerical problem involving vectors. So what is parallelogram law of vectors? Okay, they asked in your regular intermediate exam also. So parallelogram law of vector is nothing but if two vectors acting at a point making an angle theta with each other are represented both in magnitude and direction by the adjacent sides of a parallelogram, then the diagonal drawn from the same point will give you the resultant magnitude and direction. The meaning is, this is the meaning. Suppose one vector is in the x direction p, another vector, suppose p, direction of p is this and the direction of q is this, and then you complete the diagram into a parallelogram. Then the resultant, you know, this resultant which is passing through the origin is the resultant. Now this resultant of course has got some formula. See, its horizontal component, r horizontal component is this q ka horizontal component is q cos theta, vertical component is q sin theta, and then you have to solve this, you know, this right angle triangle and get this formula. So I am finishing my class here. In the next class from here I will explain. Thank you very much.